So this gets into what we call interval notation. So when we get into next couple units, we're going to get into domain and range, and domain and range are going to be described as an inequality or also using interval notation. So these are going to be interchangeable topics that they'll go back and forth between inequalities and interval notation. So if I look at the graph here, express the graph shown in color using interval notation, also express it as an inequality involving x. So using interval notation, one of the things we have to identify is the endpoints. So if I look at the endpoints here, notice that the endpoints are this 4 and this 8. Now the question is, are the endpoints included or not included? Since we're using a bracket, the bracket means we're including, so that's like a little solid dot there. And then since there's a bracket where this 8 is, that also means it's included. So if the endpoints are included, that's going to be described as closed. So when you see a bracket present, that represents closed. That means you're including the endpoint. Notice how there's a bracket over here. That also means that side is also a closed. So each side would be considered a closed, or in other words, we're including the endpoints. So if I'm using interval notation, what's nice is the brackets kind of go together here. The catch is when you do an interval, you have to go from left to right. So again, you have this left bound, if you will, because you can't go past 4, so there's a boundary. So we're including the boundary of the 4, and then we're going to put a comma, and then it almost looks like an ordered pair, but this is actually interval notation, so it's all about context. So since the left bound is included, we're going to put a 4 there, so that's a boundary point, and then the 8 becomes the right bound, and it's also included. So again, when you do it as an ordered pair, you have what's called a left boundary, or left bound goes first, and then the right bound goes second. So it's always this left to right concept. So if the boundaries are included, we're using brackets in interval notation. So this means all the numbers between 4 and 8, including 4 and 8. So since we can't name all the numbers between 4 and 8, because again, we're not talking just whole numbers, we're talking all the numbers between 4 and 5 as well. And remember, there's an infinitely many numbers between 4 and 5. We can't name all the numbers between 4 and 5. Because you could think 4.1, but then there's also 4.01, which is a shade smaller. And then you can go like 4.001. You keep getting closer to 4. Or getting closer to 5, you could say 4.9. You could say 4.99. Or you could say 4.999. So you can continue to get closer and closer to 5, but you can never actually get to 5 if you think of it in those terms. So again, since we can't name all the numbers between 4 and 8, we use an interval to describe that. So again, if I use an inequality, again, the same kind of concept here is we have a left bound, which is the 4, the right bound is an 8, and then we have our x in the middle. So this actually is 2 inequalities rolled into 1. So we're going to be, x is actually going to be greater than or equal to 4, and x is going to be less than or equal to 8. Such inequalities will always run in the same direction. They will always point to the left, but you read it from the middle. X is greater than or equal to 4, and x is less than or equal to 8. That's how that's kind of read, is you actually read this from the middle as 2 inequalities. So you're greater than or equal to 4, and you're less than or equal to 8. So remember, and means both pieces have to be true. Both statements have to be true. So that would be the inequality that is described here as well. So since we're including the endpoints, we have to use a less than or equal to. Less than or equal to kind of means we're including the endpoints as well.